Hello, my name is Alyssa Ellaby. I'm a part of Section 13 Biology 101. My protein is alpha epithelial sodium channel. The mutation for alpha epithelial sodium channel is cysteine replaced with arginine. Alpha epithelial sodium channel is also better known as AENAC. The disease caused by this protein is named Liddle syndrome. Liddle syndrome is a genetically interrupted disease that causes high blood pressure and hypertension. The normal function of my protein is that it's found in the apical membrane of the epithelial cells and partially in the kidney, where it plays a major part in the sodium reabsorption. The protein can also be found in the colon, sweat glands, skin, salivary duct, airway, and it's also found in animals. This protein is made up of 3 subunits: alpha, beta, and gamma subunits. These subunits are essential for transport to the membrane assembly of the functional channels of the membrane. The C-terminus of each alpha epithelial sodium channel subunit contains APPXY motif, which, when mutated, are deleted in their beta or gamma ENAC subunit, which leads to Liddle syndrome. The categorization of this protein is transport because it allows ions or molecules to spread across the membrane, and in this case, the ions are sodium. The mutated form of this protein causes it to fasten the delivery of sodium ions. This tends to happen because the mutation increases the channels at the surface of the epithelial cell, which causes it to be hydrophilic. So basically, it becomes more active when at work because it pushes out sodium ions and it creates high blood pressure and creates hypertension. So now I will show you my protein structure project. So as stated before, my protein is made up of 3 subunits. So the white tubes are alpha subunits, the B tubes are beta subunits, and the dark gray tubes are gamma subunits. This foam piece right here represents where the mutation occurs in the protein of cysteine, replacement of arginine, and these 2 foam pieces on the side of the beta and gamma is the original or the previous mutation. The normal amino acid group, the normal amino acid is cysteine. The functional group is sulfhydryl, and this amino acid is hydrophilic. The mutated amino acid is arginine. The functional groups are carboxyl and amino groups, and this amino acid is hydrophobic. The main functional groups of the original protein is carboxyl and amino groups. The original protein is hydrophobic and polar, and since hydrophobic, it can't bond with water, where the mutated form of this protein, cysteine, is hydrophilic and nonpolar. This protein is hormonal. The protein gets smaller after the mutation, and this protein really allows the cells to regulate the sodium throughout the body. My model limitations are that the model does not have bonding sites around the subunits. It doesn't have the effect of amiloride in the normal model, and the model depicts only has subunits, not full proteins. Thank you.